Okay, so let's take a look at a couple of examples of doing this. Before we do that, I want to give you one quick mnemonic, a way to remember the sine, cosine, tangent, and that would be SOHCAHTOA. I write it vertically because I think that helps me sort of process what I'm doing. So it's telling me that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So it's kind of a quicker way or a nice way to remember those three. And then if you just remember which ones are the reciprocals of others, then that will basically take care of all six. So the sine's reciprocal is the cosecant, CSC, cosecant. Cosine's reciprocal is the secant, which is right above me here. SEC, it's not sec, it's secant. And tangent's reciprocal is cotangent. So tangent and cotangent are the easiest ones to remember. Duh, they have the same name. But for secant and cosecant, I remember them by thinking that two cos don't go together. So I have a sine and a cosine. So for cosine, its reciprocal is not cosecant because that's two cos. So cosine's reciprocal is secant. And sine's reciprocal is cosecant. So I don't know if that helps, but it helps me. So maybe it'll help you. So here's what we're going to do. We're going to take this triangle, which by the way, did not have a theta written in it. So please label this angle right here as theta. That's what this symbol is. It's a Greek theta. It's very commonly used for angles. So I forgot to include it in my picture. And now we're going to try to find the sine, the cosine, and the tangent. Let's start there. And then we'll go back and do reciprocals to find the other three. So we start at our theta, and we know sine is opposite over hypotenuse. So the opposite, remember, you go directly across from that angle, the side that doesn't make up the angle. That would be 24. And the hypotenuse in this case is 25. So my sine would be 24 over 25. If we wanted to, we could add in right now its reciprocal. Since this is sine, cosecant is the reciprocal. And we would just flip it. So hypotenuse over opposite. Cosine. Cosine, I'm going to start at my angle and find the adjacent. Adjacent would be 7. It can't be 25 because that's the hypotenuse. So the adjacent over the hypotenuse would be 7 over 25. And then if I flip that, that would be the secant. And last but not least, the tangent, TOA, opposite over adjacent. Opposite over adjacent. So 24 over 7, making the cotangent 7 over 24. So I've got a couple more pictures here. And you'll notice in number 2, I only have 2 sides of my triangle. I won't be able to answer everything without all 3 sides. So I'm going to need to use the Pythagorean theorem to find the missing side. So what you need to do is identify which side is the hypotenuse, because that's the one that always has to be by itself on the other side. Remember, it's a squared plus b squared equals c squared, and c is the hypotenuse. So in this picture, this triangle, 10 is the hypotenuse. So I'll just call this a or b, it doesn't matter. A squared plus 7 squared equals 10 squared. And then I'm going to solve this for a. Let's see, that would be 51 if I subtract, and I'm not going to get a nice whole number, so I'm just going to leave it as the square root of 51. Okay. So I'll replace that with this. don't think I can simplify that square root. 4, 9, 16, none of those go in. And now I should be able to fill in my sine, cosine, and tangent, and then just flip them for my cosecant, secant, and cotangent. All right, remember, you have to start at the angle. So my angle is here. So hypotenuse is always 10, but my opposite will be the square root of 51. So sine, so opposite over hypotenuse. Here we go. Now, when you flip that, in my world, I don't care that there's a square root in the denominator. But in some math corners, they're going to want you to rationalize that. I can't remember if your homework system makes you rationalize it or not. If it tells you, you put it in and it says, no, it's not simplified, then you're going to have to do that. Okay. But I'm fine with this. You'll notice that when you rationalize, all it does is put the square root on top and make it a whole, or an unsquared, a whole number on the bottom. Okay. All right, let's do cosine. Start at my angle, theta. Adjacent, cosine is ka, adjacent over hypotenuse. Adjacent over hypotenuse. And then flip it for secant. Last but not least, tangent, start at theta, opposite over adjacent. And again, when you flip that, I'm not going to rationalize it, but you might have to. Okay, not too bad. So I'm going to have you pause the video and go ahead and try number 3. It looks like you're going to have to find that missing side first using the Pythagorean theorem. And as you found that side, you might have realized that I didn't give you a theta. Let's put it here at A. All right, now you can create your ratios. All right, let's take a look to see how it went. So I'm missing the hypotenuse. So I set up my 2 squared plus my square root of 5 squared equals c squared. Square root of 5 squared is just 5. So I end up with c equals 3. Then once we established where our theta was, opposite would be root 5, adjacent would be 2, and hypotenuse would be 3. So you could fill in your so, ka, toa accordingly, and then flip them to get your remaining ratios. Okay, and then I want to just answer one quick question here. So I want you to think about this for a minute. Why is it impossible for the sine of any acute angle, so that would be these less than 90 degrees, and notice we're not talking about the right angle, less than 90 degrees, why is it impossible for the sine of one of those to be greater than or equal to 1? Why can this not be greater than or equal to 1? Well, what do you know about the hypotenuse of a triangle? It's always the largest side. Can it ever be equal to one of these other sides? It cannot, right? So the hypotenuse is always greater than the opposite. That is the nature of a right triangle. So therefore, when I divide opposite by hypotenuse, it's always going to be less than 1. What about cosine? Is that true for cosine? Cosine is adjacent over hypotenuse. So yes, this is also true for cosine. What about tangent? Tangent is opposite over adjacent. So the hypotenuse isn't involved anymore. It could certainly be that root 5 divided by 2 is bigger than 1. In fact, it is, right? So no, this is not true for tangent. Tangent can be greater than 1.